Hello, it's Saturday, and I will um, show you how to do the Chapter 8 um, review in today's section. So first, there's a Chapter 8 formula sheet right here. So if you go to Canvas, go to the modules, check on Chapter 8, you can see the Chapter 8 formula sheet, okay? So this is the page of the formula sheet that you can print it out and use for the test. All right, so that is the one that we are using for today. Remember the homework, you will see all the section homework, but for the chapter 8 test, we only tested the section 8.1, 8.3, and 8.4. The rest of the section, you will only need to do the homework, okay? And most of the rest of section about a house mortgage, about a car loan, credit card, those you pretty much only doing like the concepts, okay? Knowing some of the concepts. The calculation is very limited, all right? So again, for the testing question for this chapter is only up to 8.4, all right? So let's go ahead and get started with the test review question, which I posted in here. The first one here is use the percentage formula A equal to P times B to answer the question below. All right. First, what percent of 2.5 is 0.4? What percent? So first, when we look at the percentage in here, what percent? If we do not know, we can using the X or using the whatever, ABC, whatever you feel comfortable. What percent? We can say X percent of is multiplied of 2.5 is equal sign, okay, equal to 0.4. Now I want to solve for X, right? So in order to solve for X, you divide both sides by 2.5, and then you will multiply by 100%. Okay, so let's do the decimal point first, and then we will change it into percentage. So let me go ahead and open the calculator. Again, the calculator TI-83 and 84 are allowed to use in this course. And that's the calculator we are trying to show you, all right? So what percent of 2.5 is 0.4. So X times 2.5 equal to 0.4. So we have a 0.4 divide 2.5. That will giving you 0.16, okay? 0.16. So we have a 0.16. And this one is wrong to the 2 decimal places as needed. And we're going to multiply 100%, okay? So multiply 100%, 100 is kind of 100 over 100. And that is equal to 1, right? Everything times 1 still equal to itself. So I move using the 100 times 0.16 and keep the percentage in here. So 0.4 is 16% of 2.5. Okay, so that is our first question. Just simply calculate a percentage. The second one, suppose that the local sales tax rate is 3% and you purchase a car for $20,500. How much tax is paid and what is the total car cost? Okay, so first, how much is the tax pay? Oh, the price is 20,500, right? And then the local tax rate is 3%. So you multiply by 3%. That is your tax pay. All right. 3% is kind of 3 divided by 100. So we're gonna move 2 decimal point to the left. So that's 0.03. Okay. So we're gonna use 20,500 times 0.03. Again, I can use the calculator. Okay. In here. Okay, so we have a 2,500 times 0.03. That will giving you 615. All right. So basically, you just paying $615 for the tax. All right. So the total amount of tax is $615. What is the total cost for the car? Well, you have to pay the amount of 20,500 plus tax, right? The tax is 615. So that will giving you 21 $1,115. Okay. That one. So that would be $21,115 for the total cost of the car. Number 3, an exercise machine with an optional price of $900 is on sale at 19% off. What is the discount amount and what is the exercise machine sales price? Well, so the discount amount here is 19% off, right? So the discount amount will be using the original price times 19%, okay? And that is 900 times 0.19, and you can put it in a calculator. So that's 900 times 0.19, that will give you $171. All right, so that is $171 discount. So what's the sales price? Well, you have original 900 minus the discount price is 171. So that will giving you 729 for the sales price. Okay, so that is one way to do this one. Another way to do this one here is I can just using the 900 times 1 minus 19%. That would be my sales price directly from B, right? So basically, instead of paying 100% of 900, I will just pay 81%. Okay, I'll just pay 81% for the original amount, and that will giving you 729 directly as well. Okay, so that is another way to do the same question. Let me know if you have any questions. All right, so those are all still all section 8.1. Okay. All right, let's go to the number 4. Okay, so number 4, when you buy something, it actually costs more than you may think. It is in terms of how much money you must earn to buy it. For example, if you pay 22% of your income in tax, how much money will you have to earn to buy a used car for $78,000? Okay, so since you have to pay 22% in income tax, okay, So the money you will have to earn to buy a used car is unknown. Okay, so how much money you have to earn to buy a used car? So we can always set the unknown as X. So I need to earn X amount in order to buy this one, right? So the used car cost is 7,800 plus I had to pay 22% of the tax. So what's the 22%? Well, 22% of the tax is my total amount. How much money you will have to earn? I say X. So I will have to add a 22% of my income tax in here. Okay. So now we want to solve for X. Solve for X. All right. So we can convert this one into decimal point. So let's point 22 x, and then we minus this one on both sides. All right. So now we are giving you me that will be 0.78x equal to 78 hundred. And then we divide by both sides by 0.78, and then we cancel decimal point away, or you can just using the calculator, right? So that we are giving you 10,000. Okay, you mean you 10,000. So basically, you will have to earn $10,000 in order to buy the used car for 7,800, because you have to pay 22% of the income tax. Basically, you will pay $220 dollars $220 for the tax. Okay, in here. So that is number 4. So again, this is still section 8.1. Okay, so we skip the section 8.2, the tax, the income tax calculation, but we will go into the section 8.3 for the simple interest, and the section 8.4 will be the compound interest. Okay, so those are the sections you will see on the test. I want to go ahead review you the formulas that you can use on the test. Okay, so this is the formula sheet for the chapter 8. You will need to know what kind of interest rate we were talking about. So the simple interest rate, interesting, is equal to PRT. P is the principal, R is the rate, T is the time. Okay, for the future value A, you're using the principal plus the interest. So that if you put everything in, you got this formula. All right. So let's look at this one right here. Determine whether the statement is true or false. If the statement is false, make the necessary change to produce a true statement. In here, if 6,000 is borrowed at 9.2 for 2 months, the loan value, the future loan value is $92. Well, apparently the future value should include the interest rate and the original amount. So if you can see this one, $92 is less than the original amount. So apparently this one is false. Okay, so we can ignore the A one. The B says statement is false. The loan value, the loan future value is 92. No, this is not right. Because it's still less than 6,000. So anything less than 6,000 is incorrect. Okay. So the only statement here that's possible correct is C. The statement is false. If 6,000 is borrowed at 9.2% for 2 months, the non-future value should be greater than 6,000. All right. So that is the only one that is greater than 6,000. So I don't really need to calculate this one. I can answer this directly. All right. Okay. Number 6, the principal P is borrowed at a simple interest rate R for a period of time T. When a simple interest in O for the use of the money, assume 365 days in a year. All right, so P is equal to 2000, R is 5%, T is 1 year, right? So we want to see um, find a simple interest in O for the use of the money. Okay, so this one we only need to find the interest. So we said that earlier the interest in I here is equal to PRT. So P is the principal, which is 2000. R here is interest rate. 5% you must convert it into decimal point. So you move 2 digits to the left. So interest rate here is 0.05. T here must be in a year. So that's multiplied by 1. So that's 1 year, right? So if you calculate this one, that will give me you $100. Okay. So that means if you borrow $2,000 for a year, and interest rate is 5%, you must pay the interest for 100. And what's the total amount? Total amount A here is usually using the principal plus the interest. So the total amount you must pay is 2,000 plus 100, okay, or $2,100 for the future value or the total amount you must pay. But $100 is only for the interest rate. All right, so that is the simple interest calculation. Number 7, the principal P is borrowed and the loan future value A at a time is given. Determine the loan's simple interest rate R. Okay, so we're gonna use the formula in here as I showed you earlier. The future value A and P at the time of a simple interest rate R for T years giving A equal to P times this one, okay? Or we can just using A is equal to P plus principal plus the interest. And the interest is PRT, okay? The interest for the simple one is PRT. And then you can take the P out, you can factor the P out. So this will, taking P out, this will be 1 plus RT. All right, so that is the formula. We see that earlier in the formula sheet. So we want to find the R. So R is the unknown, okay? So we have A here. A here is 5900 equal to P is 5,000, okay? 1 plus R. R is unknown. T here is 2 years. So that is 2. So right now we need to find the R, right? We can divide by 5,000 on both sides first. Okay, so that make it easier. All right, it divided by both sides by 5,000. This 5,000 is gone. So that is 1 plus 2R, right? 1 plus 2R. And we want to find the R. All right, so we can have a 1 plus 2R equal to this one. You can go ahead, do the calculation. 5900 5900 divided by 5,000. Okay, so that's 1.18. All right, so this is equal to 1.18. And then we minus 1 on both sides, right? And that will giving you 2R will equal to 0.18. Okay, you minus 1. And then we divide by both sides by 2. All right, so that will giving you R here is 0.09. If you multiply by 100%, okay, that will giving you 9% of the interest rate. Okay, so round to the nearest tens, so we're gonna have a 9.0. All right, 9.0. Nearest tens, that means 1 decimal point. All right, so we want to keep 1 decimal point, but in here we have an integer, so we're gonna just add a 9.0 in here. So that is how you find the interest rate for these 2 years. Simple interest, okay? So you plug a A in, plug a P in, plug a T in, and you just want to find the R. All right, let's go ahead. Look at number 8. Still the principal A is borrowed and the loan future value at the time T is given. Determine the loan simple interest rate. Well, I think we just did this one, which is pretty much similar to this one, right? Just a little bit different number. This one, so we can go ahead and do that one more time. Okay, we have A here is equal to P times 1 plus RT. Okay, and then we want to find the R. All right. So right now, A here is 9280. P here is 8000. R here is unknown. Okay. And then a T here is 2. All right. Again, we're going to divide both sides by 8000. Divide by both sides by 8000 first. Okay. This divided by 8000, this cancel out. So we're going to have just 1 plus 2R on the right side. And then we're going to just go ahead, divide by the left side using the calculator. Okay. We have a 9280 divided by 8000. Now we're giving you 1.16. So this one is equal to 1.16. All right. And then we're going to minus 1 on both sides, right? We minus 1 on both sides. So this will be just equal to 2R. The left side, 1.16 minus 1, you will get a 0.16. Okay. And then you divide it by 2 on both sides. So we're going to have R equal to 0.08. Okay. All right. 0.08. R is 0.08. You just multiply by 100%, which is times 1. And this will giving you 8%. All right. And then since you instead of round to the nearest tens, we have an integer. So 8% is equal to 8.0%. All right. So we have a 8.0% for this interest rate. Okay. So basically number 8 and number 7 are exactly the same. I'm just using a different number. Okay. So on the test, you will see the similar one. You might not see the number exactly the same in this example, but you will see the similar question. All right, number 9, suppose that you borrow 2,000 from a friend and promise to pay back $3,117 in 3 years. What is the simplest rate you will pay? All right, so basically this one is still similar to this one we have earlier. All right, this one is still says simple interest. So when we have a simple interest, we can use this formula. This is for the simple interest. I equal to PRT. This is also for the simple interest. Okay, so this one is the simple interest formula. Okay, you want to choose the right formula in here. So it's pretty much similar. You're gonna pay back this much. So that is your future value. Your principal here is 2,000. Okay, and R here is unknown. R here is unknown. T here is 3 years. So that's 3R. Okay. And in order to do this one, we already know we're going to divide by both sides by 2,000. Okay. And then this side 2,000 will be gone. So this will be 1 plus 3R. All right. So we're going to go ahead and divide by this one. 3170 divided by 2,000. Now we're giving you 1.585. All right. And then we minus 1. Remember, 1 is on the integer part. So we have a 3R equal to 0.585. Okay, 3R equal to 0.858. You divide it by 3 on both sides. So R will be, let's see, 0.058. 0.585 divided by 3. Okay, so that will giving you 0.195. Multiplied by 100%. So move 2 digits to the right. So that will giving you 19.5%. Okay. So if you promise to pay back this $3,170 from borrowing 2,000, you are paying 19.5% of the interest rate, the simple interest rate. Okay, let's move on. This section in here. The principal represents the amount of the money deposited in a saving account subject to a compound interest at a given rate. Okay, so remember this one is a compound interest. All right, since it's a compound interest, we cannot use the simple interest rate. So these formula are for the compound. These formula are for the compound interest calculation. Okay, if you look at the formula sheet we provide earlier in here, this one is the simple interest, right? And the compound interest is in this one. Continuous compound is this one. So these formula are all for compound interest, okay? Uh, you will choose this one is calculate the future value. This one is calculate principal. This one is calculate continuous compound. Continuous compound, that means it doesn't count how many times compound in a year. Okay. If you use this formula, that means you compound n times in a year. N is number of the compound times in a year. So for example, if it's compound monthly, n will equal to 12. That means you compound 12 times in a year. If you compound quarterly, okay, so n will equal to 4. So that means you compound 4 times in a year. Okay, so that is the compound interest. We have a principal, we have interest rate. We compound semi-annually, so that means n here will equal to 2. All right, that means compound 2 times in a year. First, you want to see how much money there will be in the account after the given number of years. So that means after 4 years, right? So we will use the compound interest because this one is already telling you it's a compound interest. The principal here is 7,000, okay? And then you have a compound 4 times, so you were using the first one, which is with n. N is 2 times semi-annually. N is 2. All right, so R here is 3%. You will need to convert it into decimal point. If we're using the formula here, okay, and then N here semi-annually, N here is 2. So 2 times NT, T here is 4. All right, so you will need to calculate inside the parentheses first, and then raise the power before you multiply 7,000, right? So I usually calculate inside this one first, and then 2 times 4 is 8, okay? And then this one, you will calculate inside the parentheses first, okay? So the parenthesis is 1 plus 0.03 divided by 2. They will give you 1.015. All right. So this 1.015 must raise to the power of 8 first before you multiply 7,000. Okay. You can put this one directly into the calculator. So I have a 7,000 times 1.015 raised to the power. Look at that. This is the power of 8. All right. And then we hit enter. All right. So that is the amount. For the money, we usually round to 2 decimal points. So for 0.448, we're going to round to 0.45. So it's 7,885.45. Okay. So that is the amount after 4 years. Okay. All right, the amount of the interest earned. Unfortunately, for the compound interest, we don't have a formula to calculate interest by itself. But we're gonna using total amount equal to the principal plus the interest. So the interest, we are using the total amount minus the principal. This formula can use for anything, for the compound and for the simple interest. All right. So we have a total amount is 7,885.45 minus the principal. Principal here is 7,000, right? Okay, so we have $885.45 for the interest. Okay, so for the compound interest, that's the only way you can calculate for the interest using the total amount minus the principal. All right. So that is how you calculate the compound interest. We can use one of these formula. Um, when you use A equal to P times E to the RT, this one is also used for the compound interest. But this one is you compound continuously, which is you cannot count how many times you compound in a year. So that is using this formula. Okay. All right, let's look at another compound interest formula in here. Um, an account has a rate of 4.5% for the effective years if the interest is compound quarterly. To view some of the, click the icon to view some of the finance formula. Okay, so for the in the provide A is the in the provide this formula here. A is the balance in the account after T years. P is the principal investment. R is the annual interest rate. N is the number of compounding periods per year. And Y is the investment effective annual year in decimal form. Okay. All right. So we have a amount. We have an account has a rate of 4.5%. Okay. And this rate here is the R. We want to find the effective year if the interest is compound quarterly. So compound quarterly N equal to 4. That means 4 times in a year. All right. So this is the annual rate, 4.5%. Okay. So what's the effective annual year if the interest is compound quarterly? All right. So we can just using this formula. Okay, this it doesn't matter how much is the original amount. We just only want to find the interest rate, effective rate. So y will be equal to 1 plus r converted into decimal point, move 2 digits. Okay, so it's 0.045 divided by n here, which is 4. Okay, and then we're going to raise to the power of 4 and then minus 1. And this will giving you the effective annual year for this compound quarterly. All right, so just go ahead and plug it into the formula. Again, we have a parenthesis. Okay, so I'm gonna just put it in the 1 plus 0.045. Okay, divided by 4, and we need to use the parentheses raised to the power of 4. Okay, make sure you move the cursor down and then minus 1. All right, so let's see how many decimal point we need to run to the nearest hundreds as needed. So that means we need to have a 2 decimal point after you convert it into percentage. So before the percentage, we need a 4 decimal point. Okay, so 4 decimal point in here will be 0.04576. 6 need to run up to 8. Okay, so this will be 0.0458. And then we multiply by 100%. Okay, so that would be 4.58%. 4.58%. All right, so if you have this account rate is 4.5 and compound quarterly, okay, compound quarterly, the effective annual rate will be equivalent to 4.58 compound in a year. Okay, so that is this one called the effective rate, because sometimes people say, hey, I'm giving you 3% compound monthly, and some people say I'm giving you 3.2% compound quarterly, and some people say I will giving you 2.9% compound daily. Well, which one is better to invest? Well, we don't know unless we all convert it into annual year. Okay, So convert into annual yield. We'll be able to compare apple to apple and to see which one is better rate. Okay. So this one 4.5% compound quarterly is equal to 4.5% compound annually. So that's the effective annual yield. All right. So hopefully this will help. I will give you one more example for this one. So if I have another one is called a 4.6% rate, okay? My second rate is 4.56%, and this one is compound annually. Well, yeah, compound annually compared to 4.5% compound quarterly, which one is better? Well, since this effective rate is only 4.5%, right? My annual compound rate is already 4.6%. So this one will be a better choice if you have money to deposit, right? And then some people say, I will giving you 4.3% and I want to compound monthly, for example, okay? So which one do you choose? So we have a choice of 1, choice of 2, choice of 3, okay? We know the choice of 1, 4.5% compound quarterly is equivalent to 4.58 compound annually, right? And how about my 4.3%? I said, I promise you, I want to compound every month. Okay. So is this a better choice than the 4.5% compound quarterly or not? All right. So we can also find the effective year. Okay. So this one will be 1 plus 0.043 monthly and will be 12. Okay. So we can find out the effective rate for this one. Just have a quick calculation. Okay, so that's 1 plus 0.043 divided by 12 raised to the power of 12. And then we're going to minus 1. Okay, so that is only giving you 0.439. Or equivalent to 4.39%. Okay, so the conclusion here is it doesn't matter how often you compound. I think the interest rate, still determine most than the compound times, right? So even I promise compound monthly, but with a 4.3% rate, my annual rate is only 4.39%. Okay. So if someone give me the 4.6% annual rate, I will pick this one will be the best one. Okay. All right, hopefully this will help you with this section.